Hello Stat 200 and welcome to Lesson 11. This week you're going to learn about chi-square tests. These tests can be used when we're examining the counts from one or more categorical variables. Chi-square is a common distribution. It's similar to the t-distribution in that it varies depending on degrees of freedom. It's different though in that it's skewed to the right. These tests are covered in Chapter 7 of the Lock 5 textbook. Before you begin, there are a few topics that I recommend that you review: frequency tables, contingency tables, and risk. These three topics were covered in Lesson 2 and will come up again this week. The numbers that you see here are the sections in the online notes where these topics were first introduced. There are three key topics that you're going to focus on this week: the chi-square goodness of fit test, the chi-square test of independence, and relative risk. You'll see that the two chi-square tests share some of the same formulas and some of the same procedures. The difference is that the goodness of fit test is used with one categorical variable, while the test of independence is used with two or more categorical variables. Let's start by looking at a chi-square goodness of fit test. This test is used with one categorical variable with more than two categories. You can think of this as an extension on the single sample proportion test that we learned earlier this semester. A goodness of fit test with two categories is equivalent to a single sample proportion test. If you have only two categories, the single sample proportion test is typically preferred. If you have more than two categories, then you would need to use the goodness of fit test. In this test, the observed frequencies are compared to the frequencies that we would expect if the null hypothesis were true. This will also be true for the chi-square test of independence. The first step in computing a chi-square value is to determine what all of the expected counts are. An expected count for a cell is equal to n times p, where n is the total sample size, and p is the hypothesized value of the proportion for that group. This is the proportion in the null hypothesis. Expected counts along with observed counts are then used to compute a chi-square test statistic. You'll see some examples of this in the online notes and textbook this week. Minitab Express will compute all of these values for you, but you should understand where they come from and how to interpret them. We will be using the 5-step hypothesis testing procedure to conduct these tests this week. Step 1. Check assumptions and write hypotheses. In order to approximate the sampling distribution using a chi-square distribution, all of the expected values must be at least 5. If any of your expected values are less than 5, then you cannot use the chi-square distribution. You could, however, conduct a randomization test. StatKey will conduct a randomization test for you. There's an example in your textbook, and you may have to walk through one of these on your lab assignment or homework this week if you have a case where this assumption is not met. The hypotheses are going to be dependent on your research question. Many times you want to know if all of the proportions are equal. Here we have an example like that with 4 categories. If the 4 categories were all equal, then all of their proportions would be 0.25. The null hypothesis does not need to take this form, though. It is possible to hypothesize different proportions for each category. All of those proportions, though, must add up to 1. Step 2 is to compute the test statistic. We've already seen this formula. It compares our observed and expected counts. Step 3, determine the p-value. The goodness of fit test uses a chi-square distribution with k minus 1 degrees of freedom, where k is the number of categories. Step 4, make a decision. As always, if p is greater than alpha, fail to reject the null. If p is less than or equal to alpha, reject the null. Step 5, state a real-world conclusion. This is where you would go back to your original research question to state whether or not you have evidence of a difference in the population. Steps 2 and 3 can be conducted with Minitab Express. You should not be worrying too much about the math in this lesson. You should focus on the underlying concepts. While you won't need to compute the whole test statistic by hand, you will need to know how everything is computed and interpret it all. For example, you'll need to know how to interpret an expected value, and you'll need to know how to compute an expected value. You just won't need to do the entire procedure by hand. On the lab assignments and when you're working in the Wiley Plus homework, you should be using Minitab Express whenever possible. Let's move on to the chi-square test of independence. This tests for a relationship between two or more categorical variables. In this course, we'll only be looking at examples with two categorical variables. It is possible, with slightly more sophisticated software though, to look at more than two categorical variables. But in this course, we're only going to do what we call a two-way chi-square test of independence, so we'll only be working with two categorical variables at a time. Each variable may have two or more categories. The observed frequencies are compared to the frequencies that we would expect if the null hypothesis were true. The test statistic formula here is identical to the one that we saw for the goodness of fit test. The expected count is different because now we're working with two variables. The null hypothesis is also going to be a little different here. Remember that we're looking for a relationship. So the null hypothesis is that there is no relationship, that the variables are independent. If the variables are independent, then this formula gives us the number of cases that we would expect to see in each cell. Again, we'll use the 5-step hypothesis testing procedure. Step 1, check assumptions and write hypotheses. Again, all expected counts must be at least 5. If this assumption is not met, then you could use a randomization test, which StatKey can run for you. Here are the general forms of the hypotheses. The null hypothesis is that there is not a relationship between the two variables. The alternative is that there is a relationship between the two variables. When you're writing out your hypotheses, you should replace the two variables part with the actual names of the variables. Don't just copy and paste these generic hypotheses into all of your tests. Step 2, compute the test statistic. This is the same formula as for the goodness of fit test. Step 3, determine the p-value. Now the degrees of freedom are equal to the number of rows minus 1 times the number of columns minus 1. Step 4, make a decision. If p is greater than alpha, fail to reject the null. If p is less than or equal to alpha, reject the null. And finally, step 5, state a real-world conclusion. This is where you would go back to your original research question and state whether or not you have evidence of a relationship in the population. Minitab Express will compute the test statistic, degrees of freedom, and p-value for you. It also gives you the options to request the expected values and chi-square contributions for each cell. You should be able to interpret all of those values correctly. The last topic that I want to cover is relative risk. You'll see this used sometimes with chi-square tests of independence as a measure of practical significance. It's the ratio of risks from two different groups. Let's look at a quick example. 25.3% of World Campus undergraduate students identify as racial minorities. 19.4% of University Park undergraduate students identify as racial minorities. We take the proportion of World Campus students divided by the proportion of University Park students to find a relative risk ratio of 1.304. To interpret this, I would say that World Campus students are 1.304 times more likely to identify as racial minorities compared to University Park undergraduate students. This concludes the Lesson 11 overview video. If you have any questions this week, please post them to the Lesson 11 discussion board in Canvas.